Whose phone is that?
That sounds like my phone.
Excuse me, could you shut your phone off?
That is my phone. It's gotta be here somewhere.
I can't believe this.
Oh. Oh, there it is.
Okay, let's see what kind of talent we can look through here today. You put this in all the trades, right?
Yeah, it's
Okay,
done.
Good. I'm gonna need a male and a female voice, and I need somebody with energy. Keep an eye open for energy, something fresh, because this stuff is like, yeah, it's dry, it's safety, you know?
Safety. It's a movie about safety?
Yeah.
Who would want to watch a movie about safety?
Very few. Here we go.
Fly me to the moon. Let me play among the stars.
Excuse me. What are you doing?
I got what it takes to be the next American Idol.
No. That audition is down the hall. Next.
Is this thing on?
Next.
Where's the dance floor? And what star is my partner?
There is no dance floor and there are no stars.
I'll have to be careful not to trip.
No tripping, no high heels. It's a movie about safety. Next.
I am a survivor.
What?
You gotta pick me, cause Survivor is my favorite show.
This is not a TV show. It's a movie.
Does anybody survive?
They all survived. It's a movie about safety. What do I have to do to get some talent?
Would you like a voice talent with that hamburger and fries? How's this? Safety. Uncover the competitive advantage.
That's the voice.
Aztec Industries, a company moving America from rock to road, building and restoring America's transportation infrastructure. It's an engaging view. Robots working at lightning speed to frame the Jeep Wrangler on a production line that is unmatched for speed and safety innovation. This is KUKA. It's a smart machine from CAMotion that uses motion control to precisely pick up and lower loads. But what's even more surprising is what happens when people and the robot try to occupy the same work location. Every year, about 260,000 Opals come off the line at this facility in Belgium, headed for over 100 destinations worldwide. Aztec, KUKA, CAMotion, Opel, they make safety a priority, and in the process are uncovering the competitive advantage.
It began some 30 years ago. Machine builders in Europe and North America experienced a huge paradigm shift with the advent of PLC technology. It changed forever the way that engineers designed and wired machines. But at the outset, the technology wasn't always reliable. So regulators on both sides of the ocean excluded PLCs from playing a role in the design and implementation of machine safeguarding systems.
In the 1970s, when PLCs came to market, it really very quickly created two layers in the architecture of a machine. The automation architecture, where a PLC would control the machine, and a separate layer of technology to do the safety and machine guarding for operator safety on the machine.
But there were no consistent standards in place for machine design safety, so it was not surprising that injuries increased. In response, workers' compensation groups from around the world began a movement calling for regulations to protect workers. Europe was the first to respond.
In Europe, we have the European directives which cover the application areas of safety-related fields. Maybe, for example, the machinery directive. But the European directives does not give any detailed measure or guideline how to fulfill the requirements. And this is done or described in European standards.
While safety in Europe was mandated and legislated, in the U.S. it continued to be viewed as something that needed to be done to comply with OSHA, a cost burden, a deterrent to productivity.
In the 80s and 90s, this rampant technology continued to explode at a very fast pace. However, the safety layer continued isolated in its own environment. And the results were that many customers were forced to choose between productivity or safety. Those that chose safety experienced a lot of intermittent downtimes with the machines, and it would have a negative impact on productivity.
Over the years, local standards emerged in different countries addressing safety and machine design. But the standards varied widely. All of that was about to change.
In the mid-1990s, spurred by shrinking trade barriers and improved technologies, the time was right for globalization and harmonization. Europe led the way.
The international standards, the IEC standard, especially the general standard IEC 61508, was a basic standard for the design, development of safety-related programmable systems. This standard was developed in international working groups.
What really happens in today's world is that compliance with regulation in any country is a given. And the higher level that you now strive for on getting common globally is conformance to harmonized standards that with risk assessment will give you what top management is asking for.
In this changing world, technology often surpasses the standards. But more recently, standards are responding with rapid change as well.
Here in the United States, the safety landscape began to change as early as 1999 with standard for robots, RIA 15.06. One of the most significant things was the risk analysis requirement that came out of that updated standard.
The second major change was NFPA 79 in 2002. Still somewhat unknown, this standard signals a major change for OEMs and end users. In the past, the standards precluded use of automation, and safety had to be hardwired. But in 2002, NFPA 79 safety standards were rewritten to be simpler. As a result, companies are moving from hardwired dedicated safety to the Integrated Safety PLC. Aztec Industries, based in Chattanooga, Tennessee, moves America from rock to road, building and restoring America's transportation infrastructure. For the Asphalt Group, times are especially demanding. Roads throughout America are crumbling because of years of inadequate maintenance. At the same time, asphalt roads have been proven cost-effective to construct and maintain, and durable. So it's no surprise that demand for new products, both here and around the world, has skyrocketed. The group manufactures portable, relocatable, and stationary asphalt plants, applying creative thinking to a traditionally low-tech industry. Mark Harnett of Aztec noticed a trend.
The CE came over from Europe, and all of a sudden we were faced with directives that we didn't understand. They were very gray, very bold, and the big part of all of it was really documentation. And all of a sudden you had to have a formal technical file that described the hazards and how you're going to protect people from it, and go into a 10 times the level of depth that we ever had to do before.
The machines which Aztec builds require a high level of safety. After all, the hazards are significant. Burns, crushing, pinch points, electrical shock, just to name a few. Up until 2 years ago, all the safety required for these complex asphalt operations translated to complex wiring from station to station, and operators had limited or no feedback from the safety relays. Aztec saw that simplification of the entire system would increase both safety and overall performance of their products.
the first thing we got into was doing distributed process control. Okay, and that was coming out with components that were shipped here from the U.S. They were pre-wired, and basically we could test as components. And we did it through Profibus. And the next thing that followed very quickly was ProfiSafe, which meant we could start to integrate safety right into the same structure and put it into the reporting of the system and make it a whole lot easier to troubleshoot than having the old hardwire system that we used to supply before.
By integrating safety, Aztec has realized some significant benefits, including cost-effective compliance, faster setup and commissioning, and extensive diagnostics.
What it really means is that we've opened up doors for our business in other countries, because if you go through and you look at like Australia, they're very, very similar to CE. Okay, it's almost a match. Japan is probably a little bit tougher even, but all the European countries and even some of the Central American countries now are conforming to using the European model as a role, and it just makes it a whole lot easier when you go in there and you can say, hey, I've got the most sophisticated control system and integrate safety and everything else with it.
In 2004, OSHA reported the fines for violations exceeded $85 million, with over 70% of them in the serious category. In 2006, OSHA identified and sent letters to more than 14,000 workplaces, urging them to take action to remove hazards. The message was consistent: do something about safety. OSHA fines are stiff and go directly to the bottom line, but experts point out that there are other considerations.
Focusing on the traditional "am I compliant" with my regulatory agencies in the U.S. may be missing the boat when I take a look at the competitive global challenges.
To be competitive, companies need to understand regulations and standards. But there are so many that it's confusing. Here's what you need to know about a few key ones to get a clearer picture of what must be done. First, at the most basic level, any machine that creates a hazard must be safeguarded to protect the operator and other employees. NFPA 79/2007 has just been approved and was published for distribution in October 2006. A new edition eliminates the requirement for a separate control element for the final removal of power when using a safety-certified drive. The ANSI B11 series of machine tool safety standards is another important set of standards. In fact, OSHA can assess violations referencing these and other consensus standards.
Some of the most important documents coming out are not the specific standards, but the new collaborative technical reports. ANSI Technical Report 3 is the foundation for task-based risk assessment that infuses itself through the entire family of standards. The new report being worked on for the integration of SAFE and Lean is really a seminal work.
While the standards have often been viewed as the domain of those in the health and safety area, that's changing. Today, management at all levels should know about a standard titled Occupational Health and Safety Management Systems. Approved in July 2005, ANSI AIHA Z10 is the first time in the U.S. that there's been a national consensus standard that applies to organizations of all sizes and types. Z10 provides the methodology and framework to integrate occupational health and safety into an existing management system. And the implications will be far-reaching.
If we want leaders to lead safety, then we have to put things in a language that they use on a daily basis. Z10 will help people better align what they do into the fundamental core business of any organization, because it creates a foundation for safety through design.
What's becoming obvious to many is that standards are about more than just compliance with OSHA and avoidance of fines. Standards are about doing the right thing for the health and safety of individuals, and at the same time uncovering the competitive advantage.
What industry is going to see is a flood of standards that are all in rewrite status right now. Some have just completed their updates. All of the standards are now acknowledging these new options and these new technologies with regard to fresh and new ways to think about providing operator safety on machinery.
Risk. It's all around us, every day. We all know that there's no situation that is risk-free. So when do we accept risk? And how much risk is acceptable?
Risk is acceptable under 3 circumstances: when it's insignificantly low, when we're sure it's worth it, and when we do not know it's there. And that's the whole point of the risk assessment.
People are drawn to risk assessment for very different reasons. Whatever the driver, one thing is becoming more and more obvious. Risk assessment works, and it takes work.
Risk assessment is really a journey. It's not an event. It's not something that you do once and you're done.
It takes time, interrupts people, 2 to 3 days on a typical machine. But after that, it gets easier and easier each time you do it.
Today, we tend to do a lot of safety work after we release the product, after we release the system. And tomorrow, what we want to get to in safety through design is getting us to the point where we're doing safety up in the design phase.
There are a number of different methods and tools available to do risk assessment, but generally the process is to identify the hazards, assess the risk, reduce the risk, and then document the results. For example, the new packaging standard that applies to both end users and suppliers of packaging machinery does not require that the level of risk is 0. It requires that risk is reduced to an acceptable level. Of course, what's acceptable is somewhat subjective, and that means you need to get comfortable with the subjectivity. In the area of machine safety, many start with the hazards of the actual machine. But Bruce Main, author of Risk Assessment, Basics and Benchmarks, discusses a slightly different and fresher approach.
One of the newer aspects of risk assessment is the task-based approach. And task-based is really where you dig down and understand what people are doing with your systems, your machinery, your designs. And it's by doing task-based that you can really identify hazards that you don't otherwise see and then reduce risks associated with those.
That's where you need to focus your efforts. Don't get hung up making it a scientific exercise. It isn't.
New tools like this software guide you through the risk assessment process. It's not an expert system. It doesn't tell you what to think, but it guides you on what to think about. So it helps you to identify users, a list of users that might be involved in your activity and the tasks that they are performing. The next level, you look at hazards, and you're able to identify then hazards associated with the tasks. Now, what you get from this is a documented risk assessment that's required in the different technical standards and reports.
Sometimes hazards are designed into machines or systems. That's because the tasks are not anticipated. This occurs on both older and newer machines.
In all the years I've been doing safety and working as an engineer, I've never seen a circumstance where an engineer identified a hazard and didn't handle